Okay, I'm testing this bit transformer now. It's got a thicker laminates and it's got more winds on it. And this one I just left the primary as it is, which is 12 24 gauge wires in series. Each of these wires is 42 feet long. So whatever 12 times 42 is, that's the overall length of the wire after you series connect them all. So this is taking 120 volts right now from the grid. And I tried some different resistors, and this 90 ohm resistor, it makes what I see as a 88-degree phase shift. And I say that because, sorry about the flashing, looks to me like 5.5 spaces to the phase shift. And overall, one cycle is 21.5 spaces, minor square divisions. The small spaces within the big squares, the bigger squares. And for peak to peak, I'm saying 18, might be 17 actually. Let's just say 18 spaces peak to peak. The amperage is the slightly angled to the right. The voltage is the tall one. So there's the data you need. So I wrote it down, 18 spaces peak to peak for amps, and it's a 0.05 square divisions. 360 degrees is 21.5, and the phase shift is 5.5. Now, what I want to do also is the overlap period, where the volts and the amps overlap. That's going to be this area. Followed by this area. So I want to draw a picture, shade those in. What I've done here is so that area of overlap here is 7.5 spaces horizontal, 8 spaces vertical. This triangle over here is 5 spaces across and 9. So I could do what I did before with the DC, and I could calculate power by the overlap periods here. I'll do that a little later, but so right now that's what this is. If you do it, 21 360 degrees by 21.5 is, I believe, 17. 16.7. That's how much each of those little tiny spaces is worth between the square divisions. Let me do that one more time. 360 divided by 21.5 equals, 360 divided by 21.5. There. 16.7. Okay. And it's 5.5 spaces, so times 5.5 equals, it's 92. 92 degrees. I'd say 4.5 now. Okay, well, whatever. It's right around 90 degrees with a 90 ohm resistor. Secondaries are in series. Each of these coils is 23 ohms. So there's that test. I wanted to verify that this is what it is. I put a 20 ohm resistor instead of a 90, and it's 111 degrees phase shift. So anyways, I guess this is going to be it for this quick thing here. Testing the other bit I have. This one, which I was driving with 12 volts with the inverter here, I've hooked these. This has 16 wires when I wound it, and I took 8 of them and I connected them in series with another 8. So this is like a bifilar, multi-filar coil with 8 parallel winds that connect in series to another 8 parallel winds. So 8 wires together of 28 gauge makes a pretty thick wire here. So that's the primary I'm driving with 12 volts going each way, so it makes AC, and then it makes AC high voltage on the output with these are 13 ohm coils here. Actually, these are 23 ohm coils. Sorry about that. 23, 23. These are 13, 13, 13. So I did a bunch of tests. I'm going to make another video right after this when I tested this inverter, and I used an analog meter, and I kind of made a table of different inputs in amps, and I'll let you see that video after this one. Okay, thanks for watching.